So thank you again for the introduction and thank you for the opportunity to speak to you all. So let's just kind of start with it. I'm just going to kind of go over something that I worked at in my PhD at UGA looking at the effect of circulation fans. So managing wet litter. It's been and has been one of the top challenges for, I think, producers all around the world. It's particularly nowadays, it's all we talk about. And why? Well, if you look at the headlines lately, everything is about animal welfare. And what includes in animal welfare is litter moisture control to better paw quality. So with all this pressure from our customers, from restaurants, from the public, it's really put a lot more pressure on producers and how they manage their birds and how they manage their litter. So what can we do if we want to manage and maintain dryer litter? Well, it's pretty much driven by three main factors. And those three main factors is fresh air, heat, and air movement. I don't know if you all participated in the webinar, I think 2 months ago, where Mike Zarek and Mark Dunlop kind of went into this. Fresh air, you need to obviously exchange it, remove that wet or moisture from your house. You also need to heat the air, and air movements involved. Now, that seems pretty simple, three things. So why is litter moisture control such a headache for everyone around the world? Well, pretty much it comes down to cost. Now, ideally, producers would maintain a pretty dry house because dry house means pretty much dry litter. So really our target in a perfect world would be under 50%. But in reality, like most of us are familiar, we really don't do that. This is just a survey that I did a couple years ago in the wintertime in the US and Southeast Georgia, where we put some sensors into some houses just to kind of get a feel of what are people actually doing. We say we want people to do 50% or below, but in reality, you can see that the data shows that really people are managing about 70% or higher. Now, why is that? Well, just like I said, it's cost. So let's see what it would cost those growers if we asked them to keep the dryer house that we want. If they were going to go from 70% to 40% humidity, you can see that it could increase their cost by almost 95%. Super expensive. Okay, so maybe about 70 to 50%. That still could increase their heating costs by almost 45%. So we can pretty much see here, it's pretty reasonable why people don't want to keep a dry house, because it's just simply, it's too much on their pocketbook. Now again, like I said, life would be great if the producers could keep and maintain an RH of 70% or greater, and get dry litter, but the fact is, you can't get dry litter if your house has a humidity of 7% or higher. I mean, you could, but it's just really hard. So, maybe producers don't need to maintain such a low humidity to get drier litter. Alternatively, maybe they could just have a little, go to a moderate relative humidity, because at the end of the day, you still need a drier house than 70%. But again, let's just try and see if we can meet these producers in the middle so we don't cost them too much money. So, okay, if we ask them, let's keep your humidity around 50 to 60% and then increase the amount of air movement over the litter surface. So what could producers use then to increase the air movement over the litter surface? Because, you can't really use an exhaust fan. Well, that's where circulation fans come into play. Now, most farms, at least in the US, actually already have circulation fans in place, and they've been around for 20, 30 years. Why? Because 20, 30 years ago, we figured out that these fans could actually help redistribute hot air from the ceiling back towards the floor, and that helped them on energy cost. But really, these fans then were only designed to do just that. It really wasn't to create a lot of air movement at floor level because of the fear of chilling your chicks. But again, we didn't do that, but they did a really good job at redistributing hot air. But just like we learned before at the beginning of this presentation, is air movement is a critical piece when it comes to maintaining drier litter. And the research shows way long ago, back in 2001, that if you have enough air movement, you can actually dry your litter. So you can see here in this study, they compared less than 0.25 meters per second to greater than 0.75 meters per second, and the litter moisture was about 10% lower. So to achieve that kind of air movement, we kind of have to think outside the box a little and use more powerful circulation fans that can move more air versus the traditional circulation fans. Because again, these basket fans, and these are, actually kind of newer, they just can't produce the kind of air movement we need if we're thinking about drier litter. So I keep talking about, that these traditional circulation fans don't produce a pound of air movement. So what's really the difference? So here you can see a contour map, and it's just essentially showing you the air velocity in a 40 by, technically it was 40 by, well, I guess in meters, that's 12 by 150 meters. But I just measured in half the house, and you can see pretty much you have no air movement. And when we did a little smoke test, this is the kind of air movement we were seeing over the litter surface with those low volume circulation fans. Now, again, like that study shows, if we have higher air movement, we can potentially get drier litter. So this is the kind of difference you're seeing in terms of air movement over the litter surface. So on your right side, that's the kind of air movement we're wanting to achieve if we want to maintain and manage drier litter. So how effective then is this concept if we ask producers to have a little bit of a drier house, but then also supply continuous air movement? So that's where the study came into place that I did at University of Georgia with Mike Zarek and Brian Fairchild. And essentially what we did was we took this out into the field, and we did this on several commercial broiler farms, where at each farm we essentially had two houses, where one house we had the traditional basket fans versus these higher volume circulation fans. And we did this over several flocks. So you're probably asking, okay, for some people out there, how did we place these fans? So again, this was a 12 by 150 meter house. And essentially in the brood section, we had two fans facing the front, two fans facing the back, because again, you want your circulation fans. One goal is to push your warm air towards your coldest spots. And then in the off chamber, we had the four fans facing the tunnel fans. And when we did airspeed measurements, you see in the house where we have these higher volume fans, essentially we're achieving an average airspeed of 0.75 meters per second. So I just want to help you guys just take a look at what it looked like inside the houses. So this was just one particular farm. In terms of fan model, we actually looked at several ones. This just happened to be one by Aerotech. They were 1/3 horsepower, and essentially the amount of fans how we determined how many fans to put in the house is we wanted at least enough to mix 20 to 25% of your house air volume. So yeah, this is just a cool drone video. So you can see space-wise, we tried to space it where the fans are beside the tube heaters. Again, we tried to do our best. And in terms of how it is, it's actually kind of parallel to the floor. You don't really want your circulation fans, pointing towards the ground. You could, but then you're probably going to chill your shakes. And you don't want them facing towards the ceiling, because what are you doing? You want your fans to act as a system. So all these fans are working together to push the air down the ceiling and then back towards the floor. So throughout the study and all the farms that we looked at both litter moisture as well as foot pad. Those are our main key points that we wanted to look at. We also looked at another couple things, but these are just the two things that I'll talk about. So first off, in terms of litter sampling, what we did was we focused on the sidewalls as well as kind of the center area, a little bit off the drinker line. We want to look at a bird's eye point of view. You can see here, again, those spots, sidewall, center, and then I sampled down the length of the brood area. So let's take what happened to litter moisture. So starting off, your target litter moisture, you want it to be below 25%. Why? There's just plenty of research out there showing that if you can keep it below 25%, you not only can keep the beneficial functional properties of litter, but you can also hopefully minimize, some bacterial growth and things like that. So let's just set it up. You have your house with low volume on your left and your house with a high volume or higher air velocity on the right. So this is the litter moisture before birds are placed. So you can see here we have our sidewall, center, and then down the length of the brood area. And then we have our house on the right, which is the house with the higher air volume. So before any birds are placed, you can pretty much see that the litter moisture levels in the two houses were fairly similar. Yeah, you're going to have some variation, but that's just what happens when you do studies out in the field. But overall, I can see on average, same litter moisture level. So we can see at day 7, you can start to see differences. The houses with lower air movement, you can see that it actually did dry it, which makes sense because you're preheating, but you only got about 5% dry litter. While in the houses with higher air movement, we actually dried our litter more, 10%, which is kind of cool because it kind of matches in that study back in 2001 where it showed that if you had higher air movement, you could potentially achieve dry litter, which is kind of what we saw in this study. Now just hopping over to another farm to show you some more results. You can see in the house with lower air movement, we saw much more variation in litter moisture, where you can see the sidewalls tend to be much higher moisture versus the center, while in the houses with, the houses with higher air movement, you had much more uniform litter moisture levels. So I'm someone where I love charts, I love data, but I think what really hits home is when I show people what we saw in the houses. So again, looking back at the bird's eye point of view, you can see that along the sidewalls where you had lower air movement, you had much wetter sidewalls. So when you actually walked into the house and you picked up a handful, you can see that it's that classic thing, you squeeze and it sticks together. But then in the center, we saw drier litter. So you can see if I, again, walk into the house, I pick up a handful of litter and it just falls straight out. So you're seeing that difference. There's just a lot of variation in the house with lower air movement where you have wet sidewalls, dry center. While in the house with higher air movement, we can see that we had much more uniform conditions from sidewall to sidewall. So when I walked into that house, I could walk on the sidewall, pick up some litter, falls out of my hand. I just walked 10 feet, or sorry, what is that in meters? I'm so sorry, I'm not good at converting. Walk towards the center, pick it up, and it's the same consistency. So it was really cool to see how much more uniform your house conditions were with higher air movement versus lower air movement. So skipping on to next, what about pollen quality? We did pretty simple where we just did a 3-point scoring scale where you had 0, 1, and 2. And when we looked at the first farm in the flock 1, you can immediately see that the house with lower air movement, you saw not only lesions, but a pretty high rate of lesions where we had about 10% minor, but already 60% of the birds we sampled had those severe lesions. While in the house with higher air movement, you can see that we had dramatically lower footpad lesions and it was pretty much 50-50. And essentially that trend continued for the rest of the flock. Now I do understand you guys are like, well, there's still lesions, but you can see at least it seems like we delayed the development of lesions. And in general, I know this grabs a lot, but it's just to show you that a trend. It's a lot easier to control litter and footpads in warm weather versus cold weather, but you can also see of all the, how many do I have here? 1, 2, 3. Of all the flocks that we did of this whole higher air movement, you can see that the house with higher air movement always had lower occurrences of footpad lesions. But I think what was more interesting in this study, and it's kind of logical, is how influential bird distribution was on litter moisture management. Because essentially what we figured out was that in the houses with lower air movement, there tended to be more variation in floor temperatures, where you can see here, the direct center underneath the tube heaters tended to be very warm. And then as you moved away underneath the radiant heater, it got cooler. While in the houses with higher air movement, again, we had more uniform conditions. Your floor temperatures tended to be more even versus the houses with lower air movement. And what we saw then, well, the birds avoided the hot spots because even for baby chicks, they have a limit of heat. Pretty much the floor was like, again, 43 degrees Celsius, which I think is 110 degrees Fahrenheit, is too warm for the chicks. So what happened, they actually tended to bunch along the sidewalls. So it made sense why we were seeing wetter sidewalls and drier centers in the houses with lower air movement, while in the houses with higher air movement, more uniform floor conditions, the birds spread themselves out fairly nicely. Now, just as Felicity mentioned in the beginning, she was like, part of this presentation is, can we use higher air movement without chilling the chicks? Because that's people's biggest question is like, well, it's too much air movement, I'm chilling my chicks. Well, that's what we saw. So here, what I'm about to show you is a time-lapse video of bird distribution. So this house is the house with those lower air movement or your traditional basket fans. And essentially what this graph is showing is when the heater kicks on and off. And it's like, okay, when the heater kicks on, the chicks are like, okay, it's not too hot. I'll just go back towards the center of the house. But when your heater kicks back on, the floor gets too warm. They start to spread towards those side walls again. And essentially they're just following the floor heating pattern. So when it's too hot, they'll go out to the sidewalls. When it's kind of more comfortable, they'll make their way back in the center. But in this again, but then the houses with higher air movement, you can see that, again, these are like 2-day-old chicks. They are nice and spread from sidewall to sidewall, which tells you in itself that higher air movement isn't bothering the chicks. They will tell you if it's too much air movement. And really, what are we doing? We're moving warm air for these birds. We're not moving cold air. I think Mike Zarek uses a famous phrase. He's like, a draft is only a draft if you move cold air. Well, again, in these houses, as long as your houses are tight enough, this higher level of air movement we found really didn't bother the chicks. So kind of just ending, we saw dry litter, better paw quality, improved bird distribution. Other people's comment is, well, did we have better air quality? So we were able to measure ammonia during one flock, and I looked it up. I think right now in Australia, your guys' recommendations is to try to keep it below 20 ppm, which is pretty much similar to the US. Our goal is 25 ppm. And so let's just take a look at that first flock. So we can see in the house with the lower air movement, on average, we can see that the ammonia peaked around 30 ppm. But in the house with higher air movement, you can see that we had nearly half the concentration of ammonia in that house. And it makes sense. Why? You had drier litter, so you have less ammonia. But it's just nice to see that we have data to back that up, and essentially data to back up a grower's comment, because the grower and we ourselves would walk into the house and be like, man, it smells better, it feels better. And then when we measured it, we could see essentially prove why there's less ammonia. But again, I just like to keep in mind that these results of dry litter, better paw quality, lower ammonia, it's not just increased air movement, even though I've been emphasizing that a lot. It's the combination of not only higher air movement, but managing and controlling your humidity to be within that 50 to 60% range. Because why? Well, when your humidity gets out of control, so does litter moisture. And so I suffered that mistake, one flock where I let humidity get out of control, but then it was kind of cool because I collected data on litter moisture. So this is just some data I collected. On the left side, you can see this is a house where, again, both these houses had those higher air movement going on. And you can see when we can maintain humidity between 50 to 60%, your litter is fairly dry. But then what happens when you let, or when I let humidity get out of control? Well, you can just see your litter moisture control is just out the door. We essentially are looking at a similar profile to a house that had lower air movement, but it's not really because of that. It's just, again, humidity is a big part of litter moisture control. So overall, I just kind of want to hit the highlights. What did we see by controlling our humidity and having higher air movement over the litter surface? You had better house temperature uniformity. And again, just like everything that I hit in the PowerPoint presentation, we had better bird distribution, drier litter, better paw quality, lower ammonia. But again, keep in mind these benefits, it requires a list of things. One, again, watching your humidity, proper fan system design. This isn't just popping any kind of circulation fan in there and whatever number you want at whatever spacing. There's a science to this. And so if you have questions, please feel free to reach out to me or Mike Zarek, any of them, and we'd be more than happy to help you, because I've already bumped into complexes in the US that were so excited at this circulation fan idea that they just started to put some in their houses, and then we go visit these houses and they're like, it's not working. It's like, well, one, you didn't put enough, or the spacing's not right. And so again, it's like I want to emphasize to people that we're here to help you if you want to try this out, because we want it to work for you. And then lastly, I know it's kind of off it, but potentially higher brooding temperatures, and that kind of goes back to the chilling the chicks. If your house is tight, this level of air movement really shouldn't chill your chicks. But if your houses are kind of old, which I think some of you have some older houses. This may be a little bit too much air movement, so you may need to bump it up a bit. And with that, again, I really appreciate you all listening in. If you have any questions, please feel free to let me know. Email me. I love chatting about this stuff, and I'm here to help. So thank you.
The first question is a functional question about how you measured litter moisture levels in the study. Were you able to use a probe style meter similar to a soil moisture meter, or did you have to collect samples and dry them to determine moisture level?
Good question. I wish there was a meter out there that could do that, but I did the traditional. I hand collected it and I took it to an oven in a lab and I dried it overnight, and then I measured the weight difference. So
Thanks.
If you have an idea of a meter out there, that'd be fantastic. I would love to try it.
Next question, is there any correlations between litter ammonia and bacterial growth?
I think I would look at it more of correlation between litter moisture and bacterial growth. Definitely bacteria is involved in litter ammonia generation. So I guess my question is like, what kind of correlation? Like if you have higher ammonia, do you have more bacteria growth? I could see that. But I'm also not a microbiologist. So unfortunately, I can't provide a very detailed response. Off the top of my head, sure, there's probably a correlation, but I don't know how strong of a correlation or what specifically that entails.
Related to the first question, what litter substrate did you use for the study? Or if you think type of litter could impact the results?
So I guess I'd like to understand litter substrate. So are you talking about like the bedding material of the litter, or
Yes,
would you be able to elaborate?
the bedding type.
Okay, so in the US on these farms, again, US is all about reused litter. On the farms that we studied, they had not removed litter for like 10, 15 years. So could it be different if this was like fairly new litter, like rice hulls? Possibly, because again, bedding material can really affect its ability to evaporate as well as absorb moisture. But all these farms, we use pine shavings. But at that point, I couldn't tell if it was pine shavings because it was just essentially poop that had accumulated over time. But possibly, and that's why there's still a lot of work that needs to be done on this. Like this was just a starting point there again. Like that's why I've been chatting with Mark about all the things that we still need to look at. So that's a good question, and that's something that we need to look into.
What was the ammonia sensor that you used?
It is the Dole 53, which actually, if you see in the background, I have 6 of them hanging. Yeah, well, I was calibrating them, but yeah, so it's Dole 53. They're produced by Dole Sensors. They're fantastic. Again, we did actually evaluate them for like 3 years, and they're pretty much the only sensor we know of that was specifically made for an agriculture setting. And yeah, they were comparable to our $10,000 ammonia sensors. So they're very nice. They can hook up to a poultry house controller, and you can just leave it there. So that's the one that I used.
Did the poor results you have you've shown come from studies with reused or fresh litter?
These were reused litter. We didn't look at fresh litter because it's not very common for farms in the US to have fresh litter.
Have any studies been done with high air movement and FCR?
Oh, okay. Did you? Okay. Oh, look at performance. Yes, we actually did. But this is just something I want to like a disclaimer. Measuring performance out in field studies is very difficult because there's so many things out of your control. But to answer your question, we did look at weights. We also did look at water usage. And from our data, we didn't see a difference in performance, which is good because that shows you that, hey, I can have high air movement, but I'm not impacting bird weight. So in terms of FCR, we were not able to look at feed because trying to split feed on farms is a whole task, unfortunately. But so I'm sorry about that, but we did measure weights.
We battled to keep our litter dry, especially in the winter rain season. Any suggestions?
I'd love to talk to you more because we could talk for years. It's because I need to first understand like what kind of house, because she said you have old conventional open-sided production houses without heaters. that's a tough one. That's something that I don't think I can answer right here, but if you reach out to me, we can talk it through just to kind of, because it helps me understand, okay, what is your litter like? Like, at what point do you start to see it fall apart? Because that's kind of where you want to work backwards from there. So yeah, I would need to talk to you a bit more.
Can we,
So I'm so sorry that I can't really provide you suggestions now. But if you just email me and we can work it through and then see if there's anything that I could suggest.
okay, now I'm just conscious of time, and as you said, we could talk all day, but thank you so much, Connie. And one of the comments, which I think sums it up, is well done, you rock. So
Oh, thank you so much. I really appreciate this.
thank you very much, Connie.